Hey there YouTube, AJ here, and I'm here to talk to you about a subject that might be kind of sensitive. Do you need a 3D printer to build your hot rod? Actually, no, it's not sensitive at all, but should you consider getting a 3D printer if you are building a hot rod or have project cars, etc.? I'm actually going to tell you, you might want to think about it because I'm actually using this for quite a few different things now. But let me step back here. About 6-7 months ago, about the same time I got this little guy. Did I tell you all I'm a grandpa now? My oldest daughter made me a grandpa in July. So anyway, around that same time, I picked up this 3D printer. I've been wanting one for a long time for all kinds of different projects. But I had several things related to my car and motorcycle hobby in mind when I did it. Everything from using it to make tools and parts. And you're saying, well, wait, does that print metal? No, it doesn't. It prints plastic, and there's different types of plastics. But the thing is, you can still use this to make parts, and you can definitely make plastic parts. So let me run you through basically what I got going on here. I bought a Bambu A1 printer. Hindsight being what it is and what I've learned about 3D printing, if I was going to do it again, I might go with the, I think it's the X1, which has an enclosure on it because of certain materials. So far I've printed PLA Plus, and PTEG filaments. And I'm not going to get into the alphabet soup of what all the different filaments mean and what you can print with them and what you need to print, because that is a whole genre, and 3D printing in itself is a very cool hobby. But I'm not going to, there's other places you can look all that stuff up. I'm still learning myself. But I have printed some stuff for my car in the background here. So what I've been doing, like, the last month has been a good example. The last 3 weeks, 2 weeks ago, I was in New Orleans for work. The week after that, I was in Florida for work. And this past week, I've been home, but I got sick. I still have a bit of the flu going on, and I couldn't work on my car. So, while I'm traveling, it's hard to get a good chunk of time to go out to the garage to take on a major metalworking project or whatever. And if you know anything about these car hobbies, people tell you that, getting a car to 80% done isn't that hard. It's that last 20% that takes up most of the time, all the little details and everything. And so in the background, in between working on projects, things I haven't been showing you, I've been working on some of the other little parts and pieces I'm going to need when I get to the end. And during these times like this where I've been traveling or sick, if I can get a little bit done here and there on these other little pieces and parts, I'll be that much ahead when I get to that point where I actually need to do that. But anyway, back to the 3D printer. Like I said, mine's open, doesn't have an enclosure. When you go to print in materials like ABS and carbon fiber and things like that, you need different heats, and some of those materials are sensitive to even airflow in your room, so it can mess up your print. So that's why they have enclosures, to get higher heats and to keep the air still inside of it. I've got an idea. There are some things I want to print out of ABSs, but I'll need an enclosure for that. I think I'm just going to rig my own enclosure around my entire system. Basically, enclose my whole tabletop here with a box. I think I'll be able to get around it with this one. Anyway, we'll find out when we get there. Back to today's video. What am I actually using this for so far? Well, I have been designing actual parts. I have been designing parts to come. So let's show you the first thing here. So my Dietz headlights only came with one of these shrouds, whatever you want to call this thing, and one glass lens. I got a great deal on them. I think I got the pair for 30 bucks. And yeah, everything else is okay except for this lens and these. Well, I did find another pair of the shrouds actually in Spain, and shipping cost me more than what my lights cost me. But now I have two good shrouds. But these little lenses have been impossible to find. So I designed up a lens out of 3D plastic, and I'm still working on the formula to get this as clear as can be, but I'm using this orange transparent filament here. And then basically this is still a work in progress, but at least for the time being, I do have a workable solution. I have a light that fits my covers, and it will transpose enough light to be seen, I think, in the daylight or especially at night. So I'm going to keep trying to make this better, and we'll cover that one later. But, oh, don't break. But lenses are one definite possibility that you can make with a 3D printer. They have different colors of transparent filaments. I already have a spool of yellow down here someplace, or amber, that I'm going to try and make another version of this out of, see if that's any better. Anyway, the other thing I've been working on is I am making molds for parts that I will eventually cast out of aluminum. Like this one here, this mold is to go into my generator bracket, like so. And then after I modify the clamp, I will be able to put my generator that's smaller than the original Ford generator into this bracket. And it'll have a pretty cool aluminum piece in there. I think will not only look good, it'll function well. And I think it'll be kind of cool. So eventually I'll be casting this out of aluminum. And then I have some other molds I'm working on for parts. Core mold, mold for the part, that I'll also be sandcasting out of aluminum. So I got all these coming. I'll do videos, especially on this one when I get there. That's just some examples of some stuff I've already started working on. It's completed parts, some things that I have done. I've been working on my dash knobs. Most of my dash components are going to be coming out of a 1959 Sprite. I have Smith gauges and all the controls from one. And I'm going to be making those. I'm just going to be making those work in my hot rod. The original knobs, some of them were in bad shape, some of them were in okay shape, but they're just plain black. And I want something a little nicer. Originally I thought about just printing ivory knobs, but I ended up going, I'm going to go, orange is going to be an accent color on my hot rod when it's all finished. So I decided to print them in orange. This one is on, it's just a simple on-off switch. I'm planning to run one fog light, so this is going to be the fog light switch. I have this knob, which is the choke and heater control. This was originally just a heater control. I'm changing it to work my choke and my heater. I have this old signal switch that when I got it, didn't have a knob on it. The chrome polished up really nice, so I want to clean this up and make this work. And I printed a knob for that. Just a simple light switch, 2-position light switch. Knob for that one. And then I got a little knob here that is just a W for windshield wiper. Now, in this video, I'm going to show you how I do all that to make a knob for this. This is the original, this is a little push pump that was a windshield wiper screen on the Sprite. And I'm going to make a knob for this to match the rest. And hopefully you'll find it interesting and see it's really not that hard to get done. And I mean, kind of cool, I think. Let me know what you think about it in the comments. I'll be with you after we get the knob made. Well, the first thing we need to do is actually create a 3D model of the knob. or the object that you want to make. And you got to do that in some kind of drawing program. I use a free version of an app called Onshape for my iPad Pro. And I like it because it's similar to the CAD programs that I've used before. It's a little harder to learn if you have no CAD experience, but if you have ever used a CAD program before, it's not too bad to learn, and there are tutorials on YouTube that you can learn it with. A lot of people use a program called Tinkercad, which is a simpler version of a CAD type program. I don't like that because it doesn't have a lot of the options and features of the CAD programs that I'm used to. So for me, it's harder to do things that I want to do. Regardless of what drawing program you choose to use, you have to learn how to draw a model in 3 dimensions. Now, in Onshape and other CAD programs, there's a feature that allows you to draw just part of that drawing and then extrude it into a 3-dimensional shape. And so what I'm doing here is I'm actually just drawing, if you look at the cross section of the knob, I'm drawing 1/2 of that. I'm basically drawing the right side looking through the knob. And once I get that done, I will go ahead and take this and do what they call a revolve. And when I revolve the drawing, the 3-dimensional object will appear. Now you may notice here that I'm using both solid lines and dashed lines. The dashed lines are what we call reference lines. They're not actually part of the drawing. They are just there for me to get dimensions to make reference points that I can actually use to draw the solid outline of the knob itself. That way, I don't have to have lines part of my drawing that don't need to be there. When you go to turn this into a 3D model, the reference lines are ignored by the programs. I guess I should also point out that I'm drawing all of this in millimeters. So the dimensions you see me adding in there are in millimeters, which is kind of a pain because most of my life I spend in the imperial, inches, feet world. But millimeters are a lot easier for my 3D printer to understand for some reason. Every time I try to draw something in inches, I have scaling issues, and I've just found that it's simpler just to draw it straight into millimeters from the get-go, and then it will render correctly in the 3D file. Okay, with that curved top that we just put on there, we've completed the profile of the drawing. Now we just need to connect the axis on the left side from the top to the bottom, and that will give us the axis that we're going to revolve this drawing around to get our 3-dimensional knob shape. Okay, there you go. Now we have a 3-dimensional knob shape, but we're not finished yet. We still have some other things we want to do. One thing we have to do is put a hole in the bottom of the knob that we can tap later for the threads to attach it to the pump that I'll be using it on. To do that, we're going to turn the knob to the bottom, and we're going to draw a circle on the surface of the bottom of the knob right in the center, and the right dimension we need for using the tap for the thread size. Then we're going to take and extrude it again, but this time instead of adding to the drawing, we're going to click remove on the extrusion, and it's going to be like a negative. It's going to actually remove part of our solid model. Now this gets a little tricky, what I'm going to do next, and I want to add my text to the top of the knob. And I will be printing that with my 3D printer in a different color than the main knob color. So what I have to do is create a plane that's the same distance off of the top face of the drawing, and create a plane that is at the top of the knob itself. And then I will go and draw my text on that plane. So now that I've entered the text that I want on the knob, I have to go in and select my font that I want to use it for it. And I'm going to use the same font I used on the other knobs. And here's the tricky part, and this did take me quite a while to figure out. This was not a simple, other CAD programs I've used, it's been a lot easier to add text to a drawing than this one. So anyway, what I basically have to do is you need to use the box lines on the drawing of the text and distance them from your center lines and to enable to get the drawing centered on the object that you want it. And then you have to dimension the height of the drawing, and it takes some trial and error to get it to fit in where you want it. Now I need to extrude the text itself down into the knob. And I don't want it to go too deep into the knob because you don't want to be printing the gold all the way through the entire knob. But once you extrude it, first it extrudes it the wrong way, so I switch it to where it extrudes into the knob and then set the height, and now it's about 2 millimeters below the surface, so the writing will be part of the actual knob itself. Okay, drawing complete. Now we put it into the Bambu Studio program and select the materials and densities we want and change the letters to the gold filament, and we're ready to print. So now the 3D printer will go through its startup routine, getting ready to print everything. Down here on the control pad, it gives you a picture of what it's going to look like. Hopefully this shows up, I can't tell. And it also tells you how much print time you have. It's going to be 2 hours, 23 minutes to print this little knob. So it takes a while, but that's because I'm printing it 100% solid. That way I can polish the knob and make it, look better. If you print, and that's because I'm using this transparent filament here. If you're using a solid filament, you can print these with less infill down to like 10%, even less if you want. That way they're more full of air and it takes a lot less time to print them. But since these are control knobs, I want them to be completely solid, so they're going to take a while to print. And it's better if you print multiples at the same time, because when you go to change colors, you waste a lot of filament because it has to purge on each level. But I've already printed all the rest, so we're just going to print this one here, and we'll see how it turns out. You can see it's right now it's purging out the filament that was in it before, so we can start with the new filament and get going. So here we go. Here's our printed knob. Now, it's not done yet. You could use it as is, but it's not done yet. I have to tap this hole to match the threads on the pump. I want to sand and polish. And I want to sand and polish this to give it a nicer finish. Because the way the 3D printer prints in layers, you have what's called layer lines, and you might be able to see them, but if not, you can probably hear them. Listen. So basically you want to sand this down to that smooth. And then I did my lettering, I purposely raised it like this. I'm going to sand that kind of to match the contour of the knob. It'll be smooth up here on top. where the lettering at the top will blend in, but I want it to be just a little proud, so I'll be sanding that down some around the edges as it to kind of match the contour of the knob top itself, but it will still have a little bit sticking out. I want a little bit of a 3D effect on it. This is the original, This is the original 1959 Sprite knob it's going to be replacing. You can see got them pretty much dead on in terms of size and shape and everything, except for the writing on top. Weight wise, they're pretty much right on the money. They pretty much feel exactly the same way. Just got to get rid of this cheap plastic looking look on here, and to do that we're going to sand. I start with 400 and then I work my way up in grits all the way to 5,000, and once I get past 1,000 I pretty much start wet sanding everything, and then I polish it at the end. So let's get this tapped and start sanding. Okay, hopefully you can see how it's starting to polish out pretty nice now. I did have to go flush with all my letters because the E especially, the letters were just too small and the pieces were breaking off, so I couldn't keep the 3D effect. So that's fine, I'm okay with that. I was kind of figuring I was going to have to do that anyway, but yeah. Anyway, that's what it looks like. You can start to see the marbling look that it's getting. It's definitely smoother, doesn't make that cheap plastic noise. It's starting to look more like a bakelite finish versus the plastic, so which is what I'm going for. The next thing I do is I take some Never Dull polishing stuff. I hit it real fast with that. Nothing crazy. You can see how it starts to pop the color and shine more. And then for now, then I just finish it off by using some Mother's Car metal, chrome, aluminum polish stuff. Nothing crazy. When I get all the pieces made, I will end up doing once I have all the pieces made out of the plastic that I'm going to print, I will take and do a power polishing, use a buffing wheel and polish these up really good. But for now I'm just going to hand polish them and leave them in that state until I get them all done, because when you polish with a wheel, everything is really messy and it slings stuff, and I really hate doing it, but I will do it before they get installed. But for now, just this hand polishing will be fine. There we are again. Our new knob versus our original. This original knob, as you can see, says push screen washer. So that's for the windshield screen to squirt fluid onto the windshield. That's not what I'm going to be using it for. I have an idea up my sleeve I want to try to use this for, but I want to use this little pump for that, and you'll have to wait to find out what that little thing's going to be much later once the car is drivable. But for now it's ready to go back with its assembly, and looks pretty good in my opinion. So I like it. So we got our knob made and polished. Looks pretty cool, I think. I hope you guys kind of like the idea of what I'm doing here, using the 3D printer, modern technology with my 1927 hot rod. I think it's pretty cool technology to use, and I think there's a lot more to explore with it. So I'm excited you'll see more of this coming in the future. Not like my whole channel is going to be 3D printing or anything, but like I will be showing more of things I make with this in upcoming videos. So in the meantime, we have our go-go juice button, and I'm not going to let you in on the secret of what this is actually going to be for. I'm not going to be using this pump for its original purpose to squirt windshield wiper fluid, but in the future, in a video, I will show you all what it is going to be for, but that's going to have to wait until later. So until then, YouTube, later.